Hi all, and welcome to the Emergent Vision Technologies presentation. I am John Eilert, President, CTO, and company founder, and I look to provide details of what the next steps are for Emergent as the pioneers of 10GigE, 25GigE, and 100GigE high-performance camera solutions. Speeds like 10GigE, 25GigE, and 100GigE are a must-have in many applications. However, as we now launch our new EROS line of cameras, we will be leveraging our deep experience in performance applications to reliably support 10GigE, 5GigE, and lower speeds in one or many camera per server applications, with a wide variety of performance processing options in the same zero-copy, zero-loss sense. Here is a quick snapshot of the adoption of GigE Vision products ranging in speeds from 10GigE up to 100GigE. Emergent has shown how top performance can be achieved and opened up many markets, including machine vision and entertainment, to the use of such technologies. Some companies are just now leveraging our efforts towards releasing 25GigE and higher speed product, but still a ways to go to provide ratified, mature, and performance product. With such a broad range of products, we find it helpful to chart out the various resolutions and frame rates provided. At 10GigE, the products range from 0.5 megapixel at 1500 frames per second up to 50 megapixel at 23 frames per second. At 25GigE, the products range from 0.5 megapixels at 1600 frames per second up to 127 megapixels at 17 frames per second. And at 100GigE, the products range from 2 megapixel at 3462 frames per second up to 152 megapixel at 16 frames per second, with a special nod to Sony's new 100GigE worthy sensors, which we will hear about later in this presentation. For line scan, the products range from 4K at 172 kHz up to 16K at 500 kHz, with a special nod to 8K TDI at 1 MHz line rate and 16K TDI at 500 kHz line rate. We are now in full production with our new EROS 10GigE line of cameras, with all models seen here, which also includes models based on the Sony SWIR sensors. A note on SWIR: there is a lot of talk about the need to cool these sensors, but it should be noted that this is only important for exposures over 20 milliseconds over the full temperature range, which is not often required. And for over 20 milliseconds, there are certainly options to externally cool these small modules. All models are the lowest power, lowest cost, and smallest size options available. As we presented at the recent Vision Show in Germany, we have the EROS camera line operating at 10GigE speeds now, and for the RJ45 PoE version, the cameras can auto-negotiate to 5GigE, 2.5GigE, and 1GigE for lower speed operations. We do all this in an attractive 29 by 29 millimeter form factor. This is all made possible by the lowest power consumption of all 10GigE and 5GigE cameras of all manufacturers in the industry. In fact, the EROS operating at 10GigE with PoE has lower power consumption than any 5GigE camera in the industry. And very noteworthy is the feature set is not reduced compared to other models, and Emergent's same reliable and mature zero-copy and GPU direct solutions are available for an overall solution that is second to none. While Emergent has been shipping 100GigE cameras for over 4 years, the sensors, while still very good, were front illuminated. Not only has Sony announced sensors now capable of 100GigE speeds, but these will also follow their Gen 4 pixel architecture, which is based on backside illuminated sensor technologies, which allow very high quantum efficiencies for greater sensitivities, which is a great benefit when going ultra-high frame rates, where exposures need to be kept shorter. Emergent has, of course, had its own integrated Canon EF mount design for close to 5 years, but Canon EF mount is going end of life. With the assistance of the detailed Canon specification, we have completed and already shipped multiple fully integrated camera modules utilizing the new RF mount. Micro Four Thirds options will be coming soon, and many other mount options are available. For those that are not familiar, the new machine vision standard GigE Vision 3.0 is adopting Rocky V2 RDMA support, which now allows zero-copy transfers to system memory, thus equalizing performance with co-express and CameraLink HS, while allowing the use of lower-cost, off-the-shelf NICs. Since Emergent has always provided zero copy and more through our advanced and mature driver technologies, we naturally are adopting this standard, which can only strengthen our position in performance vision applications. To that end, Emergent has completed and tested this edition with a simple firmware and software update with existing hardware, which was always RDMA ready. This includes all models in the Emergent portfolio, including our new EROS models. As part of our validation process, we test and fully qualify a number of such off-the-shelf cards from our primary vendors Broadcom and NVIDIA/Mellanox, where both Linux and Windows are supported. We do remind that Emergent's own FPGA-based NIC Grabber hybrid cards remain available for those looking for truly long-term support and additional FPGA-specific features, and/or front panel trigger akin to traditional frame grabbers. And at the latest International Vision Standards meeting held in Quebec City, we participated in the Technical Committee's Plugfest event, which allows device and software vendors alike to run a series of compatibility tests. The two primary players we test for compatibility with are those of Stemmer Imaging and MVTech. Here we tested our 10GigE EROS and 25GigE Bolt cameras. Naturally, we offer our own performance software as well, which we will learn more about later in this presentation. I do feel it is important to remind about the limitations of Rocky V2 compared to Emergent's mature solutions. The primary limitations are that there's no multicasting support, which is a fundamental of Ethernet and streamed video technologies. There's no Windows support for Intel and Marvell NICs. There's no GPU Direct support on Windows for NVIDIA GPUs. The last item about GPU Direct is very important and is also a limitation of frame grabbers. Emergent, however, does have GPU Direct on Windows through our advanced and mature driver technologies. We will see later how critical this feature is for performance applications. In contrast, the primary benefit of Emergent's advanced and mature driver technologies is listed below, which fill all the gaps left by other vision standards, which essentially allows unparalleled flexibility. With the introduction of the use of TCP and RDMA for GigE Vision image transmission, we see that for some camera providers, the use of these different protocols is creating a fragmented landscape whereby different NICs and drivers will need to be supported across the industry by various third parties. In addition, not all of these protocols are zero copy or offer GPU Direct options and have all available on Windows and Linux. Emergent has you fully covered with zero copy technologies and GPU Direct support across all OSs and speeds, including 1 gig, which is important in multi-camera configurations. Here we will provide a snapshot of the features of one of Emergent's workhorses, with which one customer over the past 6 years has used in systems with camera counts as high as 512. Based on the Sony IMX530 sensor, this 25 megapixel model hits the sensor's max frame rate of 105 frames per second by utilizing the Emergent pioneered 25GigE interface. Other highlights include a wide -20°C to 50°C temperature range, a 3-year warranty, fanless operation, lowest power of 12 watts, smallest size, modular SFP28 transceiver options, flexible I/O options, and of course zero copy and GPU Direct technologies. As we will see, it is not just about the camera alone, but about the complete software and support package that further sets Emergent apart. FlexProc stands for Flexible Processing, which is the simplest way for a user to create and test their machine vision algorithms. The user can create custom CPU, GPU, and FPGA plugins and run on low to high performance hardware systems without the need to write low-level image capture code. FlexTrans stands for Flexible Transport, which is the simplest way for a user to pass image data and results anywhere in their system, and has done so using the best-in-class zero copy and GPU Direct technologies. Combined, FlexProc and FlexTrans lead to maximum performance, rapid prototyping and endless processing flexibility, and endless scalability. Let's look at a real hardware demo as per the last animation. We have 8 cameras and they all feed into one NIC and one server, and that server holds 2 GPUs. There is also an additional server which holds also 2 GPUs. This is the hardware view. We switch now to the data flow view, and here we decide what we do with the camera data. We have 8 cameras that feed the first GPU in server 1, which passes its result to the second GPU in server 1, which passes its result across the network to the other server, where we have 2 GPUs to do further processing. For this demo, we have each GPU perform the simplified task of drawing a unique color rectangle and a unique brightness within that rectangle, and we have the GPUs perform this task for each of the cameras in the system. So GPU 1 draws the red rectangle, GPU 2 the yellow rectangle, GPU 3 the green rectangle, and GPU 4 the blue rectangle. And each GPU also applies their configured brightness to their rectangular regions. The software is not limited to such simplified serial operations, and vastly more complicated configurations are possible. Our eSDK is a fully featured and very powerful SDK, which has formed the basis of some impressive applications over the past decade. eCapture Pro is built on top of this SDK, and is a UI-based program which allows rapid prototyping of performance multi-camera applications using GPUs or other processing resources via our plugin functionality. We now introduce our eSDK Pro, which is also focused on performance multi-camera systems, but now allows developers to write a very small fraction of the code required by typical SDKs in order to complete the application for a far simpler integration and quicker time to market. Recall the previous video slide showing our FlexProc and FlexTrans demo that is fully realized in hardware with 2 servers, 4 GPUs, and 8 25GigE cameras. The complete acquisition code is shown on this single slide. To implement this with a standard machine vision SDK would take thousands of lines of code. Other vendor SDKs would also have a fraction of the performance. As we see, the framework and code consists of creating one or more pipelines, creating modules or tasks that make up the pipeline, and finally connecting those tasks before running the application pipeline. On this side, we see the associated processing module or plugin code, of which the highlighted green area is the customer code designed into our module framework. Here, the customer algorithms would exist to process the images, and as shown, can also interact with custom I/O modules for controlling devices on a conveyor, for example. A new and exciting NVIDIA computer has hit the market in the DGX Spark, which is a fully integrated computer with built-in GPU and even a built-in dual-port ConnectX-7 NIC. Any emergent camera can plug directly into this unit and gain immediate access to the powerful NVIDIA Blackwell GPU via zero copy and GPU direct access. And no, these QSFP28 ports or other NIC ports are not compatible with CXP over fiber nor CameraLink HS cameras, which have opted to adopt the Ethernet physical layer from the IEEE. For these protocols, expensive adapters would be required to bridge to NVIDIA product. Here we see an emergent camera streaming at 20 gigabits per second. In the system view, we see the camera, the DGX Spark, and its associated peripherals. In the processing view, we see the camera feeding a H.265 compression plugin. Back in the live view, we start the processing pipeline, which is now compressing and storing the images to the onboard M.2 drive. It's very quick to get up and running with the DGX Spark. As we have seen many times before, Emergent has full support of NVIDIA GPUs, which seem to be increasing in performance at a phenomenal rate. Here we have provided zero copy and GPU direct for over 5 years on Windows and Linux. Here we are streaming and processing a 16K 400 kHz line scan image This computer is using an NVIDIA RTX A5000, and we are streaming images via GPU Direct to this GPU where a simple custom brightness plugin has been instantiated. The output is currently just being piped to a display task so we can see the raw and processed images in the live view. Similarly, here we are streaming and processing an 8K 1 MHz TDI line scan image. We increase the TDI stages used here to show the expected intensity improvement. As we have seen, our software and systems expertise allows you to scale system processing to meet the requirements for higher performance applications like this. Here we show how easy it is to integrate third-party devices into your eCapture Pro or eSDK Pro application via our plugin API. Opto Engineering provides LED pattern projectors. Advantech provides generic I/O cards, and we will use this card to trigger the LED. SWIR provides encoder-based rotary stages, and this stage will be used to rotate the PCBs on the turntable and to trigger the camera. The stage will provide triggers to the camera as a PCB is present. The camera will provide images via network card and GPU Direct to the NVIDIA GPU, where defects are detected using an unsupervised deep learning approach, and an action is taken by turning the LED on to illuminate the defective part with a red X pattern. To set this system up, we simply create a small plugin for each of the third-party devices and then instantiate them in either eCapture Pro or using eSDK Pro. Here is a short video of the physical setup showing the turntable, illumination, LED, and the Emergent EROS 10GigE camera. An overhead shot of the turntable highlights the need for machine vision techniques on this repeating very high-speed 8 PCB array setup. In the system view, we see the camera, the NIC port, the computer, and the GPU. In the processing view, we see the camera, the rotary stage, a number of display tasks, a couple of ROI tasks, a task to create an image array, the AI anomaly detection task, and the I/O task for controlling the I/O card and LED. Back in the live view, we start the pipeline. With the pipeline running, we see the camera output, the ROI for the PCB under inspection, the ROI for the PCB detection results, the detection heat map showing location and intensity of the defects, and finally the image array for all 8 PCBs in a rotation showing their most recent results. Here is a portion of the code that makes up the anomaly detection plugin task, which, as with other plugins, is created using the Emergent eSDK Pro plugin API. Init and dinit API are run when starting and stopping the pipeline. The process API is run while the pipeline is running, and in this case is responsible for getting the image and running the AI prediction algorithm, and then setting a flag for another module to indicate action to be taken. Here is a portion of the code that makes up the Advantech control plugin task, which is responsible for taking the flag from the anomaly detection task and pulsing the LED on the defect PCB. Here is a portion of the code that makes up the SWIR control plugin task, which is responsible for configuring, homing, setting up triggering, and running the stage. And finally, if the application is to be run in eCapture Pro, then all of this is handled in the eCapture Pro UI via drag and drop processes with plugins compiled and loaded as DLLs. If running an eSDK Pro application, then you write this code to create and connect all of the tasks and to control the application either by your own UI, command line, or what have you. For this code, you would use the Emergent eSDK Pro API. As you can see, Emergent has the highest performance camera and software portfolio, and we keep our overall product portfolio focused. We innovate, develop, adapt, and expand the markets we enter and have the foresight to do so. Please do contact us for further details, and we appreciate you taking the time to view our presentation.